So, part one, pragmatic aspects of shadecloth use. Now the Australian Standard 4174, 2018 knitted and woven shade fabrics, outlines the standard for shadecloth in Australia. This is a revised standard of one that was originally promulgated in 1994 and remains the only standard in the world that is specific to shadecloth for human protection. And the terminology of or the definitions of the various protection factors that are outlined in this standard have been adopted internationally, and you will see it often used in sample and promotional literature by all of the shadecloth suppliers around the world. And it's important to understand what these particular things mean. First of all, let's look at the terminology for rating the degree of solar protection. The diagram on the left there is a graph of the solar irradiance hitting the atmosphere from the sun. And on the scale on the y-axis, that is the vertical axis, shows the intensity of that radiation in watts per square metre per nanometre, in other words, by particular wavelength. And on the x-axis, that is the horizontal axis, it shows that the particular wavelengths. And those wavelengths vary from approximately 270 nanometres, which is a millionth of a metre, way up to several thousand nanometres, which is beyond the scope of this graph. There are three areas of particular interest. The most important, in fact, is the ultraviolet, because the ultraviolet light is what causes damage, causes skin damage, cancer and so on, but also causes fading and deterioration of fabric itself. You've got visible light, which is what we see, of course, and you've got infrared. And the various terms that are used in the standard and around the world for this are shown on the right. The first, called the shade factor or the shade coefficient, is a measure of how much radiation is blocked by the shadecloth between the wavelengths of 270 and 700, which includes both the ultraviolet spectrum and the visible light spectrum. The UVR block, which is a term also commonly used, is specific to the ultraviolet spectrum. That is between 270 and approximately 400 nanometres. And the new term introduced just recently in the Australian Standard is called the ultraviolet effectiveness, or UVE. This is virtually the same as the UVR block, except that the calculation is slightly different in that it puts more emphasis on the very damaging UVB radiation at the lower wavelengths. But we will see there is a very strong correlation between the UVR block and the ultraviolet effectiveness. There are also other terms used in the standard and frequently in the sample literature and promotional literature. The first is cover factor. Although it's defined as a specific amount of radiation of 350 nanometres penetrating the material, it is really designed to be a measure of the density of the material. It doesn't really have much relevance in terms of protection against ultraviolet light. PAR, or the photosynthetically active radiation, is a measure of how much radiation which allows plant growth to grow beneath the shadecloth. Obviously, if you are blocking ultraviolet light, you reduce the photosynthesis, and the PAR is a measure of how much that is reduced. And finally, the other term that's used often is the ultraviolet protection factor, which is exactly the same as the sun protection factor that you see in sunscreens and can be calculated from the UVR block. Now the SPF or the UPF, that factor, is a measure of how effective is the protection offered. In other words, an SPF of say 30 on a sunscreen means that if you get a sunburning dose of radiation, say in 5 minutes, then without protection than if you apply the sunscreen or sit beneath the shade cloth, then it will take 30 times longer for that same degree of sunburning to occur. And it's a very common term and well understood by consumers. Now we'll come back to those terms in a minute because there's some data which is provided by all suppliers of shade cloth which you need to understand is subject to a lot of measurement error. But first let's look at the different types of shade cloth. There are really two basic types of shade cloth. One is monofilament only, which is shown on the left. And this essentially is a knitted matrix of just yarn. On the right, you've got monofilament tape, and the tape is deliberately inserted in the weft direction to improve the shading effectiveness of the cloth. And you can see the differences between those two types of products that are shown there. If you look at the numbers for the UVR block there, you can see that the monofilament tape has higher values than the monofilament only. However, a significant downside of adding tape to it is you increase the weight and the strength characteristics and the tension characteristics of the cloth is not as good as a monofilament. And this is illustrated in this slide, and we'll come back to what those graphs mean in a little while. And you can see there's a very big difference in the performance of those fabrics when subject to a biaxial load. What I mean by a biaxial load is where a stress is applied in two directions, which is what happens in the field. The graph on the right, the monofilament tape, you can see that where the tape has been inserted, the extension in the warp direction is very much more significant than on a monofilament. And the behaviour in a monofilament is more similar in each direction. Not identical, but certainly more similar, and certainly easier to engineer than a monofilament tape, which has such significant differences. Let's have a look at the shade protection categories as determined by the Australian Standard 4174. If you look on the left column there, it gives you the value of ultraviolet effectiveness, which, as I mentioned earlier, is very similar to the UVR block. So it says, the standard says, that if you have a UVE of between 80 and 90%, that's the amount of radiation which is blocked by the shade cloth, that is classified as being effective. If it's between 91 and 95%, it's classified as being very effective. And if it's over 95%, it's classified as most effective. Now, if you convert that to ultraviolet protection factor, which we all understand, you can see that the effective is a UPF of between 5 and 10. A very effective is between 10 and 20. And most effective is 20 plus. Now, if you're used to sunscreens which give you a SPF factor of 50 or 30 plus, you might think that those values are very low. But they have to be taken in the context of what is possible with shade cloth, and also in the context that shade cloth is not usually the only protection offered. People, when they're children, when they're playing beneath shade cloth, generally in Australia anyway, are wearing a hat and clothing and sunscreen. So that the shade cloth is providing additional protection, which is at least as good as natural foliage, or better. Now let's have a look at the typical results of ultraviolet protection that is for a 325 GSM monofilament and tape. Now this table has been deliberately set up so that the first value you've got is black and the second value you've got is ivory. So black, that's at different ends of the colour spectrum, and the colours there, just below, have been arranged in the visible light spectrum. And if you go from the bottom, red, orange, yellow, green, blue, indigo, violet, the old Roy G. Biv, which is the spectrum of the rainbow. And that's been deliberately shown like that, so you can see the variation of these parameters with colour and the values for those various definitions that we have. If we start at the very right-hand side, you can see that the protection category for the Australian standard is very effective, inverted commas, for all of those colours in that Shadecloth of 325 GSM. If you look at the shade factor, remember, includes the ultraviolet plus visible light spectrum, and you can see that with the colours there is a very significant variation in this factor. Now that's explained by the fact that the reason we see colour is that some radiation is absorbed and the colour we actually see is reflected. So if you're including this in a factor, of course it's going to vary very significantly. But the difference in that shade factor is not an indication of how effective the Shadecloth is in offering protection. That is shown in the UVR block or the UVE. And if you look at those values, you can see that there's not very much difference between the UVR block and the UVE because they're measuring essentially the same thing. So there's a very strong correlation between the two. Because that UVE is a new factor that's been introduced into the Australian standard, most Shadecloth has not yet been tested to it, and it will take some time for that to happen. But because there is a strong correlation, you can still use the old factor UVR block as a confident measure of the degree of protection. And you can see with the colours there, with the UVR block, there isn't much variation. The highest is 93.8 and the lowest is 92.1. And if you convert that to a UPF factor, that's a variance of between 13 and 16. So the key point to note on that is that the UVR block, all the protection, does not vary very significantly with colour. And this is often a very big misconception that people have and choose Shadecloth on the basis of colour because the UVR block is in fact better, shown there, better for one colour than for another. But that variation, in my view, is more the result of what we call measurement error. Now what I mean by measurement error is not mistake. It is a scientific term which defines the degree of variation whenever you take a measurement. Now here we have the date of a test for 2 samples, each of 10 samples taken, right? And what they do in these tests is they average the results. Now this is for a nominal weight of 325 GSM. And you see there, okay, the actual weight, sample weight, is 306 and 286, which is a lot less. Now that's partly due to the fact that they cut a piece out of this material, a small piece, and weigh it. And it's not always cut accurately. And the fact that if you're weighing a piece about this big on a scale and trying to attempt to work out what the grams per square metre is, the error of measurement is very, very significant. And if you look at the results of cover factor, shade factor, UVR block, UVE and UPF and PAR for each of those materials, which is exactly the same cloth that's been knitted but different, very significant variation, particularly in the UVR block. So for the same colour with one test, you get an average, you get a value of 94.7, and for that same material but from a different batch, you get a value of 91.3. So what this means is that if you recall the previous slide, the variation with colour is as much due to the variation or the error in testing as it is to the change in colour. So the conclusion is that the variation in test results for UVR block by colour is probably more the result of measurement error than the characteristics of the colour itself. And while this is true for UVR block, it is not true for the transmission of heat, that is, the broader wavelengths of the solar spectrum shown here. And here on this graph you've got the solar transmission for a typical 400 GSM shadecloth. On the left you've got the transmittance and on the vertical scale, and on the bottom, the horizontal scale, you've got wavelengths showing the wavelengths beyond 750, which is the infrared or the heat transmitted. And you can see that the shadecloths in the colours, aquamarine, cappuccino, porcelain, in fact reduce the transmittance through the cloth up to 55%. In other words, that is the amount of radiation or reflected or absorbed by those colours. However, if you look at the darker colours, slate grey and black, they are far more effective in reducing the infrared radiation through the material in the order of 90%. Now that slide really confirms the bleeding obvious, as we all know that standing in the shade you feel a lot cooler than standing in the sun, and that's the reason, is that the infrared is in fact blocked by the medium under which you are standing. But it is significant if people are choosing, say, a shadecloth for a car park, then you're much better off taking a dark colour. It has far more effect on reducing the heat of the solar energy being absorbed by the cars below the cloth. Now let's look at resistance to degradation by light. Unfortunately, ultraviolet not only causes damage to skin, but also affects the characteristics of the cloth. It reduces its tensile strength and also causes colour fading. Now we did some tests before and after for a 325 GSM shadecloth, and did tests for tensile strength, bursting force and tear strength. Tensile strength is you just pull the fabric apart until it breaks. Tear strength is literally when you tear it, and bursting strength is when you push a ball into the fabric until it's penetrated. And those percentage values in the table are the differences between measurements taken before ultraviolet exposure, based on a synthetic radiation source, shown there, and after. And what you notice though, for tensile strength, allegedly, you have an increase in strength of 6.3% in the warp direction, and a decrease in tensile strength of minus 5.3% in the weft direction. And if you go across to tear strength, you see the opposite. You see a decrease in tear strength of 2.2% in the warp direction, and an increase in strength of 11.4% in the weft direction. So in other words, the complete opposite of what's actually manifest in the tensile strength area. And you also have an increase in strength in a bursting force of 12.2%. Now you say to yourself, that can't be right. And in fact, you are absolutely correct when you say that, because it is logically impossible for those results to have any significance whatsoever. They are, in fact, part of the same statistical subset. Because of the variation of measurement error, again, those results can be attributed purely to measurement error rather than the effect of ultraviolet light. And this illustrates the importance of being very circumspect and very cautious when you look at test certificates, because statistically all of those results are part of the same population, and there is no statistical significance in the difference between those results. So the only conclusion that you can draw from that is that this test has been inconclusive in determining whether or not there has been a strength loss in that batch of fabric that was tested. We go to the next, and look at resistance by light. Now the standard also specifies that we cannot have a degree of fading greater than 3 on a grayscale. Now what's a grayscale? Grayscale is a series of colours of grey ranging from light to dark that is then correlated with a series of colours, whatever they are, being lime or rust or cappuccino, whatever those colours are. The grayscale is correlated. So you look at the virgin sample and correlate that with a grey, and then say, okay, the change in colour after being exposed has been a various amount, and we reckon that on this equivalent grayscale it's X amount, ranging between 1, meaning a huge change in colour, to 5, meaning no loss in colour. And you can see the results for various product tested there showed there wasn't much difference in the grayscale after this product had been tested to the standard. Now the advantage, say what's the point of all this? Well, the advantage of this is you do get colour fading in material, and at least the standard now tells you what is acceptable colour fading. So in the event of supporting a warranty claim, for example, someone says this material has faded, you can very easily compare that to the grayscale. And if you have in your warranty saying we will meet this standard, then you've met the standard. And if you haven't met the standard, then okay, the colour fading is excessive and you need to replace the material. But it gives an objective assessment of whether colour fading is acceptable or not in a particular context. And that's why this standard is so valuable in terms of its use, pragmatic use. Now let's talk about shading. That's the whole point of putting up a shadecloth structure, is to provide shade, but it's amazing how often this basic concept is overlooked. Let's look at solar azimuth angles for Sydney, and it's important to understand what that means. There are 3 key times of the year as far as the sun is concerned, and the sun varies in the height in the sky depending on the season. The highest point is the summer solstice, which in Sydney is on the 21st December, and the lowest point is the winter solstice, which in Sydney is in the 21st of June, the middle of winter. The opposite dates apply in the northern hemisphere. And in the middle you have the equinox, which occurs twice a year, once on the 21st of March and once on the 21st of December. And equinox means equal time of day and night, and that occurs twice a year on those dates. Now the obvious point where you want to have protection is at the height of summer, and therefore the summer solstice is the most crucial part. So let's have a look at a typical structure and see what effect it has in terms of shading. And I've shown here a typical hypar structure, which is an anticlastic structure, which is a fancy term for having a structure which is in fact balanced by having a convex curve in one direction and a concave curve in the other. And that structure is particularly efficient in resisting wind loads and is often used in shade structures for that particular purpose. Much more efficient than triangles, for example. But let's have a look at the efficiency of that sort of structure, a 6.6 metre hypar structure on the Sydney Summer Solstice, that is at the height of summer. Now in the middle there, you've got an area of shade at noon, which is the green outline, and you can see that the shaded area is very significant at that time. It's giving a lot of shade to whatever you are protecting beneath that structure, be it a playground or playground equipment or where children play. But in the morning, at 10 a.m, the shade provided is a lot less. The shade provided under the structure is a lot less. And if you are shading a fixed area, such as a picnic table, then obviously it is not going to be in the shade the whole time. And similarly in the afternoon, where it occurs in the opposite direction. And if you look at the amount of shade provided directly under the structure all day, it is very small indeed compared to the overall shade the overall area of the structure. So this requires very significant thought in the design process. And let's have a look at some typical shade structures. These are very attractive structures and very effective at the noon period. You can see here that the play equipment is having a good deal of shading. And similarly with the next one. This one's a little better because it has taken into account, this is an American structure, you've used trees around there to complement the shading at those times when you are not having protection overhead. And note the lovely concave shape of this particular sail. It is very, very good, efficient. Another example here where you've got a shading structure which is utilising the natural features of the site to provide shading in those areas of the afternoon or morning when you are not getting shade directly below the structure. And this is another example for a school playground. You can see that the shading is in fact very effective at noon, but not so effective perhaps at other times of the day. And here is a clear example of where the shading provided at a time of day is not providing any protection for the play equipment below it. So in other words, the children playing on this are fully exposed to the ultraviolet radiation which this sail is designed to produce. And the fact is that triangles are not very efficient in terms of providing shade. So the message there is think about the shading that's being provided by the structure that you design and get shade diagrams done because the shade depends on latitude and the orientation of the structure to the equipment or the picnic table or whatever you are trying to protect. So that's the end of part one of this presentation. The message to take away is, firstly, do not believe that measurements of UVR block by colour in fact are significant, and that's usually the result of errors in testing. Shadecloth is very effective at providing UV protection if it's used and constructed properly, and is also very effective in reducing the heat transmitted. But always take the results that you see published with a grain of salt.